I started to do my research by reading the Magic Book article by Billinghurst. It's a very inspiring project, since it uses traditional idea of books, but making it interactive using AR techniques, which gave me the idea of making this musical. To get inspiration from this project, first I needed to understand the computer vision pipeline, which consists of sensing, perceiving, recognizing, and acting. Carmignani and Ford suggested there are 5 categories for AR. My idea, which I will talk about, would fit into fixed indoor systems because it is designed for a piano space in a building. For ideation cards, I use ChatGPT to produce a Python script which asks me the location of the cards about challenges, asks my answers, and collects my results on a table. According to this table, I had 4 challenges to think about. The most important ones are the ones about the uncanny valley and the battery life. Since it is a site-specific performance, relocation is ignored. Disruption of people around is also ignorable, since it is not unique for my performance, but it's a concern about placing a piano itself in the exchange building. I randomly picked and read the questions and opportunities cards and tried to develop my existing idea. The selected site for my performance is the exchange building piano space. The design includes measuring the impulse response of the hall and create a convolution reverb model to use in computer music to make a special effect unique to the site. Yet, it is not implemented in this prototype. My idea is based on what if the Magic Book would be like a piano score booklet. Normally, a sheet music consists of information required to realize that piece of music. What if that information was carried by butterflies like this? But this would only make a musical medium as means of communication. To make it interactive and immersive, I decided to generate a computer music and make a user do accompaniment with it, using provided information by the butterflies. I defined user tasks and created a very detailed performance notes page. If we hear an oscillator in sine wave, it will sound like this. If we add another one and change its wave format and multiply these 2 oscillators, it will sound like this. If we define formant values, it will sound like this. And if we use another oscillator to interpolate between those formant values, it will sound like this. This is how I generate sound. But to generate music, I use an old French technique from Renaissance called fabourdon, a hack for endless contrapuntal music based on certain rules. All C# scripts are coded with help of ChatGPT 4.0, using very large number of very specific prompts. To realize this prototype in Unity, first I defined a diatonic pitch table using equal temperament frequency ratios, generated waveforms and low-pass filter. Also formants as demonstrated on audio prototype. Created 3 oscillators and multiplied them. This makes a synthesizer. I used 3 of these synth systems follows the fabourdon rules in frequency intervals and called notes from pitch table randomly. Modality of this project relies on QR code scanning. I used ChatGPT to produce a script which scans QR codes using the webcam texture using Xstring library for Unity in a certain frame rate and resolution. Added triggers to certain codes affecting the objects in the scene. I used Birdflock bundle in Unity Asset Store. To create an immersive audiovisual effect, generated a shader and a script, which creates morphing between the original texture and green glowing texture with respect to the amplitude of the sound during the Mod 2. I edited landing spot prefab, made it visible since it was invisible in default, added a rotation mark for calibration and named it as A0, as it's the name of the first key of the piano. Since the distance between the keys of this specific piano is approximately 2.4 centimeters, I created a mechanism using controller button mapper, which user places the A0 prefab on the A0 key and presses a button and spawns the rest of the keys respectively, then make them invisible before the performance. For music-driven landing, I used a script which reads the note frequency from the pitch table, matches it with note name, and lands the butterflies on the related named landing spots. I used hand tag for all of the hand objects in the interaction block to be able to scare the butterflies using hands. Pass-through is needed for user to see their real environment. Controller buttons mapper is needed to calibrate the keys, toggle visibility of landing spots, or save or reset the scene. Real hands are used to help user locate their hands, use them to play the piano, and scare the butterflies and place initial landing spot. Birdflock Assets has the feature of avoiding colliders. I used scene mesh colliders to keep them inside the real environment for a better scene understanding. The Webcam Texture Manager prefab is a ready-made prefab comes with Xstring Unity library. The prototype of the piano booklet looks like this. Now, let's see some fragments from the performance. Based on user feedback, it was particularly hard to calibrate the landing spots on the piano keyboard correctly if the initial rotation of the initial landing spot is not zero. An automatic approach to key detection, maybe with using QR codes, is essential. The active method is highly problematic. Also, butterfly behaviors could be musically protocoled. For example, spinning could mean trill. Finally, which keys to press could be indicated and expressed clearer. This app is meant for only the performer themselves. The audience, people witnessing the performance, were ignored. Another QR code, which they can scan and connect the same virtual environment, see butterflies, and hear the electronic music by using their phones, could solve this challenge. The creating markers in environment in this case was by giving references to very traditional way of doing this, as in the case of Magic Book. There are always piano books on the piano in the exchange building, which is a feature of the site. Installing there the QR codes in a form of a piano book or booklet was also an artistic approach, which carries a social, historical, traditional meaning. This creates an instinct to know that QR code includes the music to perform. In traditional way of reading notation, performers usually follow the notes from a book or a paper, or their tablets or phones using PDF files. In this case, a hard copy booklet is printed, but for it was a late hour and relatively dark, PDF version via bright computer screen was used during the test. In this application, computer generates music and human listens and reacts. This is a one-way communication. For future development, creating a computer listening pipeline to react to music generated by human is highly essential.